How do we know electrons are waves? Well, the current understanding is that the electron is both a wave and a particle at the same time. Now, we certainly have a lot of evidence to support that electrons behave like particles. I mean, after all, the electron is a type of subatomic particle. It's got a definite mass, it's got a definite charge, and it's often portrayed as a solid particle orbiting the nucleus of an atom in the same way that a planet orbits the sun. But what evidence do we have that supports the idea that electrons behave like waves? Well, in one of my previous videos, we discussed how light waves can undergo interference and diffraction when passed through two closely spaced slits to show an interference pattern, which is characterized by alternating bright spots and dark spots. If you don't know what I'm talking about, check out my video on interference and diffraction, and that will shed some light on the subject. What if we did the same thing with electrons? What if we fired a bunch of electrons toward two closely spaced slits and then set up an array of detectors to see where the electrons end up? If electrons are exclusively particles, then we would expect to see two spots on the detector that collect the vast majority of the electrons, separated by the same distance that separates the two slits. But this is not what is observed at all. Instead, we see an interference pattern, suggesting that the electrons are waves, not particles. Crazy, right? But wait, it gets even weirder. If we were to turn down that electron source such that only one electron was being fired toward the two slits at a time, then we're still going to see an interference pattern. So the interference pattern is caused not by electrons interfering with one another, but by individual electrons interfering with themselves. Not only does the wave behavior of the electron explain the interference pattern, but it also explains a variety of other things as well. For instance, why the energy and location of an electron is quantized or limited to a certain discrete set of values. In addition, the wave behavior of the electron is what prevents the electron from spiraling toward the positively charged nucleus and crashing into it. And in the next few videos, we're going to explore several consequences of electrons behaving as waves. Thank you very much for watching, and have a good one.